ionization constants for acids and bases. The acid ionization constant is the equilibrium constant for the acid ionization in water. We know how to do this. K equals the product of the concentrations of the products divided by the concentration, the product of the concentration of the reactants. However, pay attention to this. Water is a pure liquid, so the concentration of water should not appear in the KEQ. So this is the KEQ of this equation. In the case of acid, it is called acid ionization constant, and we put a label subscript A here to tell people this is a K for an acid. Well, the stronger the acid, when acid is stronger, we know that when acid is stronger, the equilibrium goes farther to the right. When equilibrium goes farther to the right, you have relatively more of these ions. When you have more of these ions, Ka is going to increase. So greater Ka means there is higher percentage of the ionization, means it is a stronger acid. So the greater the Ka, the higher the percentage of ionization, the stronger the acid. Here are some data for the Ka value percent of Ka percent ionization. As you can see, the greater the Ka, the higher the percentage of ionization, the stronger the acid. Base ionization constant. Weak base dissolves in water also ionizes, and similar to the case of acid ionization constant, Kb equals the products of the concentrations of the products divided by the base only. The concentration of the base, again, liquid water, should not appear in the KEQ. In this case, because it is a base ionization, it is labeled as Kb. Again, the most common weak base is ammonia, so let's put ammonia ionization equilibrium here, and the Kb for ammonia will be concentration of ammonium multiplied by the concentration of hydroxide divided by the concentration of ammonia. At 25 Celsius degree, the Kb of ammonia is 1.8 times 10 to the power of -5. Kb is not as useful as Ka. I am not going to test you any questions on Kb in this class. So when you study, focus on Ka acid strength. Okay, the stronger the acid, the greater the Ka, the greater the percentage of ionization. And one reason that Kb, or the strength of base, is not as important as the acid is that the strength of a base can be evaluated by the strength of its conjugate acid. The stronger the acid, the weaker its conjugate base. Practice: a 0.0100 molarity solution of acid HA is 15% ionized. Calculate the Ka. All right, let's write out the acid ionization equilibrium of HA. So that's what it is. Then let's put Ka here. This is the formula of Ka. Our job is to figure out the concentration of this, the concentration of this, and the concentration of that, then put the numbers in, we're done. So before that, let's clarify this. Once you dissolve Ka in water, the amount of hydronium ion and the amount of the A minus, the conjugate base of Ha, these two should equal. What I'm trying to say is that the concentration of hydronium ion should equal the concentration of the conjugate base of the Ha. Does that make sense to you? Because both of them are produced from the ionization of Ha. And for every one Ha produced, it always generates the same amount of A3O plus and A minus. All right, now let's move on. What is the concentration of this? Oh, it is given. That's what it is. Not really. That's the amount of Ha dissolved in water. However, the amount dissolved is not the concentration in water of Ha because some of them are ionized. The concentration is the amount left over after the ionization. So if 15% is ionized, what is the percentage that is not ionized? It is 100 minus 15%. Does that make sense to you? So the concentration of Ha is original concentration multiply the percentage that is not ionized. 0.0085 molarity. This, if you understand this concept, then this is easy. Both of those will equal the original concentration of the Ha times by the percentage ionized, because for every one Ha ionized, it will generate one A3O plus and one A minus. So the amount of this one ionized is the same as the amount of this and that in solution. So it equals 0.0100 times 15%, which is that. Now, Ka equals the product of these two concentrations, which is 0.0015 divided by Ha concentration. 2 sig figs, 2.6 times 10 to the power of -4. Practice 3 practice questions. I will leave these questions for yourself. Pause the video, complete them, and unpause the video to check the answer key. See you next time.